Next example, combination with cases. If you ever approach a mathematics problem that is fairly complex, that can be easily broken down into simpler mathematics problems, that is an ideal situation for cases. And we'll see that C involves cases. Allow me to read the question. In how many ways can the coach of the debating club select a team from 7 grade 11 students? So we have 7 grade 11 students and 8 grade 12 students. If the team has, so we're going to go through various scenarios. Here's my team, or here's my pool that I get to choose from, a total of 15. What if the team had 4 members? Well, out of $15, we're going to choose 4, so that would be 15 choose 4. Now, 15 choose 4, quickly punched into the calculator, is 1,065. What if we have the same scenario and only one is in grade 11? So really what we're going to choose, pardon me, I don't know why this is going all crazy, we are going to choose 1 grade 11 student and 3 grade 12. So if we choose 1 grade 11 student and 3 grade 12, if I log back up, what I notice is that I have 7 grade 11 students. So from 7, I am choosing 1. And implies multiplication. From a pool of 8, I'm going to choose 3 for my grade 12. So 7 choose 1 times 8 choose 3, quickly punched into my calculator, that's going to be 392. So it shouldn't be a surprise that the number of the number of different ways that we can select our debate club will be less when we put constraints on. Now, let's move on to the next question. I'm just going to see the whole question again. In how many ways can the coach of a debating club select a team from 7 grade 11 students and 8 grade 12 students if the team has 4 members? So we're still dealing with the 4-member team, but at least 2 of whom are in grade 12. At least 2. Well, what does that mean? Well, from 4 members, 2 of them, at least 2, have to be in grade 12. Think about that. What does that mean? Well, it means that this could break up into 3 cases. You may not be here with me yet. So at least 2 of whom are in grade 12. So I'm going to say 2 grade 12 students. And if we have 4 members and we have 2 grade 12s, I better add 2 grade 11 students to make up my 4-person team. The second case would be, well, how about if I have 3 grade 12 students? And if I would like a 4-member team, that would mean and 1 grade 11 student. Also, what does this mean? It also means that I could have 4 grade 12 students. I could have the whole team of grade 12 students and 0 grade 11 students. Very quickly, I'm going to change this here. Keep in mind for grade 12, for grade 12, there's a total of 8 grade 12 students. So grade 12, I have two grade 12, or I have 2 students. So I can choose 8, out of 8, I'm choosing 2. And for grade 11 students, out of 7, I'm going to choose 2. In case number 2, out of 8 grade 12 students, I'm going to choose 3. And then out of grade 11 students, there's 7 of them, I'm going to choose 1. Now, my case 3, out of 8, I'm going to choose 4 times 7, choose 0. Choosing 0 students. Well, what do we do with these individual numbers? Case 1 will give a certain number of quantities, different amount of teams. Case 2 will deliver a different amount of teams, or case 3. And in English, we would say we could have 2 grade 12 students, or we could have 3 grade 12 students, or we could have 4 grade 12 students. This naturally means that we are going to add up the cases. The mathematical operation of OR implies addition in this context. So if in your calculator, if you do 8 choose 2 times 7 choose 2 plus 8 choose 3 plus 8 choose 3, I'm adding case number 2 here, times 7 choose 1 plus 8 choose 4 times 7 choose 0. And if you add up all of these cases, you will get 1,050 possible cases. If you have any questions, feel free to